Here are the answers for some of the Chapter 7 review questions. The first one that I have an answer for in the video is number 2. We're told to evaluate these expressions if n is negative 2. So replace the n with negative 2 and then figure out what the answer is. Negative 2 squared is 4, 16 times 4 is 64, and the square root of 64 makes 8. For this next one, replace the n with negative 2. And evaluate the answer. Negative 2 to the third power is negative 8. 8 times negative 8 makes a negative 64 inside the radical, and the cube root of negative 64 is negative 4. Next one is number 3. We're asked to solve this equation. So one thing that you might do is to add the 32 y to the fourth power to move it to the other side of the equation. Now we would have 162 is equal to 32 y to the fourth. Now divide both sides by 32 to get the y to the fourth alone. This makes 162 over 32 is equal to y to the fourth power. This is a reducible fraction. Both top and bottom divide by 2, making 81 over 16. And that's equal to y to the fourth. Now let's get the letter y alone by removing the exponent of 4. To do that, you take the fourth root. Taking the fourth root of y to the fourth power will create a y. Let's also take the fourth root of the 81 over 16. Now when we studied roots, we said that any root that has an even index will have two possible solutions. So we need the positive and negative sign. If the root that we were taking had an odd index, then we would not need a positive and negative sign. This makes y, and on this side we get positive or negative 3 over 2. Because the fourth root of 81 is 3, and the fourth root of 16 is 2. Number 4, we're asked to create a list of possible rational roots. To do this, you take the factors of the constant term and divide by all of the factors of the leading term. So the factors of 6 are positive or negative 1, positive negative 2, positive or negative 3, and positive or negative 6. Those are all the factors of the constant term 6. Now the leading coefficient is 2. The factors of 2 are positive and negative 1, and positive and negative 2. Now, let's not leave the numbers in this compact form. Let's actually figure out what numbers this generates. If we choose the 1s as our denominator, then we would have every one of those numerators all divided by the 1s. So that would make these answers. On the other hand, if we choose the 2s as our denominator, let's think about what numbers we would get when we divide all of those numerator possibilities by the 2s. The 1s divided by the 2s would create positive or negative 1/2. 2 divided by 2 would make the positive or negative 1, which we already have in our list. The 3s in the top divided by the different kinds of 2s in the bottom make positive or negative 3 over 2. And the 6 in the top divided by the 2s makes positive or negative 3, which we already have in our list. So this list of, is that 12 numbers there? That list of 12 numbers are the possible rational roots. Number 5, we're told that one of the solutions to this equation is 1 plus the square root of 5. We're asked to show that this expression is an irrational number. To do this, let's change this equation into its standard form by subtracting the 8 to the left side, getting equals to 0. Now let's create a list of the possible rational roots, like we did in question 4. The factors of the constant divided by the factors of that leading coefficient of 1. So that's plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. All divided by positive or negative 1. Notice that the list of possibilities includes those 8 numbers in the numerator. Now, if the equation had rational solutions, then they must come from this list of 8 possibilities. This number right here is not in the list of possible rational solutions, therefore it must be irrational. So our reasoning is that the 1 plus the square root of 5 isn't in our list of possible rationals. Number 6, we're asked to solve this equation, which is in standard form. Well, in solving the equation, maybe some of the solutions are rational. Let's generate that list of possibilities. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, all divided by the factors of the leading coefficient, which is plus or minus 1. I'm not going to rewrite these. When you divide by 1, you just get this list of numbers in the numerator. Any rational solutions to the equation must come from that list of 8 choices. Now let's simply pick one of them and divide it in there and see if it works. Maybe 1 is a solution. Let's check that. Let's use the rational roots theorem and plug in 1 and see if we get 0. 1 cubed minus 7 times 1 plus 6. This turns out to equal 0. So already we've discovered one of our solutions. It is the number 1. If there are any more rational solutions, we could choose numbers from this list of possibilities and plug them in there to see if it makes 0. Another technique, though, is to use division. If 1 is a root, then that means that this polynomial divides by x minus 1. Let's use long division and divide an x minus 1 into the original polynomial, x cubed plus 0x squared minus 7x plus 6. Hopefully you recall long division from an earlier chapter. X times x squared makes x cubed, and x squared times negative 1 is negative 1x squared. 0 subtract negative 1 makes 1x squared, and then bring down the negative 7x. X times positive x makes x squared, and x times negative 1 is negative 1x. Negative 7 subtract negative 1 is negative 6x, and then bring down the plus 6. X times negative 6 is negative 6x, and negative 6 times negative 1 makes 6. When we subtract, we get a remainder of 0, as we knew that we would, because we had already figured out that 1 was a solution. The reason for doing long division is to create this quotient, because with this quotient, we can find answers. Let's do that right here. X squared plus x minus 6 is equal to 0. This trinomial factors. We can use x plus 3 times x minus 2. In the first parentheses, we see that x equals negative 3, and right here we see that x equals 2. So I already drew a box around one of the answers. It was 1, and we just found the other two, negative 3 and 2. Those 3 numbers are the 3 answers to this equation. Now I'm skipping ahead to number 14. We're given this expression and we're asked to solve for x. So let's get the letter x alone on the left side by dividing by the cube root of b. That would make the letter x be by itself. On the right side we have b divided by the cube root of b. Now let's do some simplifying right here to make this look a little nicer. When there's a radical in the denominator, we learned a process called rationalizing. We're going to multiply top and bottom by the same thing. And what we're going to multiply by is a radical so that you could end up taking the cube root of it and get a nice result. I'm going to times by the cube root of b squared. In the top we have b times the cube root of b squared. And in the bottom, the cube root of b times the cube root of b squared makes the cube root of b cubed. And notice how that just turns out to be a b. So we have b times the cube root of b squared all over b. Now you can reduce the b's. So final result seems to be the cube root of b squared. Number 15, we're asked to simplify. We have this fraction and we're timesing by this radical. Well, in the numerator, the square root of 25 will turn out to be 5. That works out really nice. But in the denominator, the square root of 54 is not an integer. But what we can do is we can think of 54 as 9 times 6. So let's do a little bit of rewriting. Here's the negative 6/5. The square root of 25 makes 5. In the denominator, the square root of 9 makes 3. But the 6 is going to have to stay in a radical. Now we can do a little reducing. Notice how the 5's cancel? And the negative 6 over the 3 will reduce as well. So 5 over 5 just cancels away, and 3 goes into negative 6 twice. So it looks like we have negative 2 on top and square root of 6 on the bottom. Let's rationalize the denominator. Just like we did last time, we're going to times top and bottom by the square root of 6. So now we have negative 2 square root of 6 all over the square root of 36. But the square root of 36 is just 6. When you take a square root of 6 and you times by another square root of 6, that just makes a 6. Now we can reduce the 2 and the 6. This makes negative square root of 6 all over 3. Number 16, let's rationalize again. Let's times the top by the square root of 60 and the bottom by the square root of 60. So now we have 2 times the square root of 180 all over a regular 60. Well, 180 is not a perfect square, so let's think of 180 in its factored form. 180 is the same thing as 36 times 5. And I chose 36 times 5 because 36 is a perfect square. We can take the square root of it and get an integer. So now we have 2 times 6 square root of 5 all over the 60. Let's do some reducing. The 6 cancels to the 6 and the 60 reduce to 1 over 10. You know what? We can even reduce the 2 over 10. The 2 over 10 reduced to 1 over 5. It looks like we have the square root of 5 all over 5. Number 17, we're asked to simplify this. Inside the radical, we can replace 8 squared with 64. And now let's get the cube root of negative 64. What number to the third power makes negative 64? It's negative 4. Okay, number 18, we're back to a radical in the denominator. We have to rationalize. So what cube root are we going to times by? In the denominator, it's got to be something so that when you times these together, you get something that you can take the cube root of. Well, the cube root of 8 would work out really nice. So let's use a 4 in there. In the top, we have 6 cube root of 4. And in the bottom, we have cube root of 8. The cube root of 8 just makes 2. And finally, we can reduce 6 over 2. That makes 3 cube root of 4. Next answer in the video is number 23. We're asked to simplify this pretty long expression. In this first part, we have the situation with a radical in the bottom. That's where you have to rationalize. So let's rewrite the problem here and times top and bottom by the square root of 12. In the middle section, we have a, so in that case, let's separate into a separate numerator and separate denominator. Notice now that we have another radical in the denominator. So let's rationalize times top and bottom by the square root of 5. Now on this last piece, 180 is not a perfect square. Let's use some factoring. We just had 180 in another question, and we went with 36 times 5 as our way of rewriting the 180. Okay, next step. We have 18 square root of 12 all over a 12. Now here in the middle, we have 10 square root of 20 all over a 5. And now over here on the end, we have minus, and then the square root of 36 makes a 6. And that 6 will get times to that 2 right there. So we get 12 square root of 5. Let's do a little bit more work, because while the square root of 12 is not a perfect square, we can factor the 12. Think of 12 as a 4 times a 3. Likewise, think of 20 as a 4 times a 5. So this becomes 18 times 2, which is 36, and the 3 stays in the radical. Here in the middle, this becomes 10 times 2, which is 20, and the 5 stays in the radical. And then on the end, there's not really anything we can do. Let's just write that down. Final steps, we can do some reducing, like 36 divided 12. That just makes 3 square root of 3. And right here, 20 divided by 5, that makes 4 square root of 5. But the 4 square root of 5 and the minus 12 square root of 5 are like terms. We can combine. 4 minus 12 makes negative 8 square root of 5. That's as far as we can go. Number 25 has a binomial times a binomial. That's FOIL. So this one times this one. 3 times 4 is 12. In the radical, 2 times 6 is 12. Now let's do the outer product. Those two times together. 3 times negative 3 is negative 9 square root of 2. Now do the inner. Those two times together. 2 times 4 makes positive 8. And in the radical, 3 times 6 is 18. Now do the last. Takes this one and times to this one. We get negative 6 square root of 3. Okay, this right here, the square root of 12. Think about 12 as 4 times 3. This part right here, the 18. Think of that 18 as being 9 times 2. That'll let us go farther. Okay, what is the square root of 4? That makes 2. And that 2 can be times by this 12 up front to get 24 square root of 3. Okay, right here there's nothing actually to do, so let's write minus 9 square root of 2. Okay, now in this spot we can do some simplifying. What is the square root of 9? It's 3. And that 3 can get times by that 8 that was right there. That becomes 24 square root of 2. Then here on the end, there's nothing to do, so minus 6 square root of 3. Do we have any like terms? Looks like we can combine this one and this one. 24 minus 6 makes 18 square root of 3. And it looks like we can combine this one and this one. Negative 9 plus 24 makes positive 15 square root of 2. Here's the final answer. Number 26 has exactly that same arrangement, a binomial times a binomial, so it's FOIL again. 2 times 2 is 4. And then for the radicals, we get the cube root of 9. Now the outer product becomes negative 10 cube root of 3. The inner product becomes positive 10 cube root of 3. And the last becomes 5 times negative 5, which is negative 25. Do you notice anything that's going to cancel out here? Those middle terms will cancel out. So our answer is 4 cube root of 9 minus 25. Number 27, we have a fraction with a radical in the bottom. This is where you have to rationalize. So you're going to times the top and bottom by the conjugate of that denominator. The conjugate will have the same terms, but with the opposite sign in the middle. Notice I'm putting a plus sign in the middle. In the top, 6 times 3 becomes 18, and then positive 6 square root of 7. in the bottom, when we times these, you use FOIL, but notice it's that special case where everything matches and this is a negative and this is a positive. You can skip doing the outer and the inner products. 3 times 3 makes 9, and square root of 7 times square root of 7 makes 7. Okay, next step, we have 18 plus 6 square root of 7 all over 2. And now we can reduce because 18 divides by 2 and 6 divides by 2. We get 9 plus 3 square root of 7. Number 29, back to solving equations. Let's get standard form. Subtract the 10. That way you get a 0 on one of the sides. Now we can solve using whatever method they tell us to, or if it doesn't give us a method to use, we can use any way that we want. The directions don't specify a method. I'm going to choose the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. For this to work, you have to know what the a, b, and c are. So right in front, a is 1. Right there, b is negative 2. And right there, c is negative 10. Let's make our substitutions. When it says negative b, we're going to get 2. In the radical b squared, negative 2 squared makes a 4. The letter a is 1, and the letter c is negative 10. That's all divided by 2 times a. Well, a is a 1, so what's 2 times 1? That makes 2. Okay, next step. Let's work in the radical. Negative 4 times 1 times negative 10 makes positive 40. And 4 plus 40 becomes 44. That's all over 2. Now we can simplify this because 44 is the same thing as 4 times 11, and we can take the square root of 4. So we get 2 plus or minus 2 square root of 11 all over 2. Do you notice what's going to reduce? Those 2's are going to reduce. So our final answer is 1 plus or minus the square root of 11. The directions also say to give the answers to the nearest tenth. That means to give it as a decimal with one number after the dot. To do that, you use your calculator and you type 1 plus the square root of 11 and push enter. That answer is 4.3 if you round it to the tenths position. To get your other answer, type it in and use the subtraction sign. 1 subtract the square root of 11 on the calculator is negative 2.3. Okay, number 30, we're asked to solve the equation and it doesn't tell us how to do it. So maybe the quadratic formula would work again. N equals negative b, so that's negative 9, plus or minus the square root. B squared is 81. The letter A is 3, the letter C is 1. All divided by 2 times A, so 2 times 3, that's a 6. Okay, next step, let's work in the radical. Figure out what that value is. 81 minus 12 makes 69. And that's all divided by 6. Now 69 is not a perfect square, and even if you tried to factor 69, the best you could do would be 3 times 23, but you can't take the square root of 3 or the square root of 23 either and get an integer, so we might as well just leave it as the square root of 69. We're also supposed to give the answers using decimals. So like the previous question, you would type this in your calculator to find out the two answers. I'm not going to take the time to do that in the video. Number 31, we're asked to solve the equation. Let's put it in standard form by subtracting the 2 so that you get a 0 on the right side. Now we can see that A is 3, B is this number here in front of the R, and C is this number, the negative 2. Let's use the quadratic formula again. It's working really well for us. So R equals negative B, so negative 2 square root of 3, plus or minus. Now we want B squared. So what's the 2 square root of 3 squared? Well, 2 squared is 4, and the square root of 3 squared is 3, and 4 times 3 makes 12. Now the letter A is 3, and the letter C is negative 2. And that's all over 2 times A, which is a 6. Okay, let's work inside the radical there. What is 12 minus 4 times 3 times negative 2? Let's use the calculator to help. That makes 36. Well, that's really nice because the square root of 36 just makes a 6. So now we have negative 2 square root of 3 plus or minus 6 all over 6. And this is reducible because 2 and 6 reduce and 6 and 1 reduce. Let's reduce this first part. We get negative square root of 3 all over 3. And now let's reduce this second piece. We get plus or minus 1. This expression has both of our answers in a compact form. If you want to get decimals, type this in the calculator using the plus sign one time and then type it in again using the subtraction sign. Next, number 32, we're asked to solve this equation. This is the kind where you times by the LCD so that those denominators will slash away. So our LCD is going to have both of those factors in it. It'll have the t minus 2 and the t minus 1. Now I don't have a lot of room right here, so I'm going to rewrite the problem. We have our 1 over t minus 2, and then subtract 1 over t plus 1, and that's equal to 1. And I left some space here because I know that I want to times by this rather long thing. So let's times the first fraction by the LCD. Let's times the second one by the LCD. And times the 1 by the LCD. The reason for doing that is for canceling to happen. Bye-bye to the t minus 2s, and bye-bye to the t plus 1s. Oop, that was a t plus 1 right there. That crosses out. Now we have 1 times t minus 1. That makes t minus 1. And now we have negative 1 times t minus 2. That makes negative t plus 2. And that's equal to 1 times this. Well, we can do FOIL on this. We get t squared minus 3t plus 2. Now look at the left side. The t minus t cancels away. And negative 1 plus 2 just makes 1. So we have 1 equals t squared minus 3t plus 2. This is a quadratic equation because it goes to the second power. Let's get standard form. If we subtract the 1, we will get a 0 on one of the sides. So we have t squared minus 3t plus 1 is equal to 0. Now we want to solve that. It doesn't look like it will factor because I can't think of two numbers that times up to 1 and combine to negative 3. So since factoring is not going to work, let's use the quadratic formula. T equals, now we want to go negative b, so that makes 3, plus or minus the square root. Now we want to go b squared, that's 9, minus 4 times a times c, all divided by 2 times a, which is just a 2. So we have 3 plus or minus the square root of 5, all divided by 2. Here are our answers to our equation. Number 41. The problem asks us to figure out the discriminant. The discriminant is b squared minus 4ac. So figure out what a is. It's the first coefficient. Figure out what b is. It's the negative 2 square root of 10. And figure out what c is. It's the 9. And make those substitutions. So in place of b, you're filling in negative 2 square root of 10. In place of a, fill in 1. And for c, fill in 9. Now simplify this. Negative 2 squared makes 4. Square root of 10 squared makes 10. 4 times 10 makes 40. 4 times 1 times 9 makes 36. So the final result is 4. Number 42, we have an equation and we're asked about the nature of the roots, meaning are they real roots, rational roots, or what's going on? Well, let's put this in standard form. So we have 3y squared plus 5y minus 2 is equal to 0. Now we see a is 3, b is 5, c is the negative 2. Let's find our discriminant. B squared would be 25. A is the 3, C is the negative 2. What's this make? This is positive 49. Because the discriminant is positive, there are 2 real roots. One of the roots would be a positive number, the other root would be a negative number. We're also asked if the real roots are rational numbers, and we have a way to check for that. For the real roots to be rational numbers, our discriminant must be the square of a rational number. So is 49 the square of a rational number? Well, yeah, 49 is 7 squared. So our answer is yes, they are rational. So not only do we know that the answers to the equation are real numbers, but those real numbers are rational numbers. Number 50, we're asked to solve the equation. Well, the letter x is trapped inside of a radical. We need to do something that will remove the radical. How do you remove the cube root? You do cubing. Cubing is the opposite thing of cube root. If you raise this to the third power, you get the radicand. And on the right side, 2 to the third power makes 8. This is a quadratic equation. Let's make standard form by getting a 0 on one of the sides. Now let's solve this with whatever way we want. This one happens to factor as x plus 4 times x minus 3. So we see that one answer is x equals negative 4, and the other answer is x equals 3. So I think factoring was the fastest way to solve it, but you certainly could have used the quadratic formula if you wanted to. Now the next thing you have to do is you have to plug those numbers into the original problem that's in black ink and check to make sure it really turns out to be 2, because it's possible to get an answer that doesn't work. So negative 4 squared is 16. 16 plus negative 4 is 12. 12 minus 4 is 8, and the cube root of 8 is 2. Yep, this one checks out. Let's try 3. 3 squared is 9. 9 plus 3 is 12. 12 minus 4 is 8, and the cube root of 8 is 2. This one checks out as well.